How does KISCC prevent stress corrosion cracking? Have you ever wondered why some materials fail while others hold strong? One key factor is something called KISCC, which stands for the threshold stress intensity factor for stress corrosion cracking. This concept is essential for understanding how to keep materials safe from failure. Stress corrosion cracking, or SCC, happens when a material is under tensile stress and exposed to a corrosive environment. This combination can lead to cracks forming and growing, which can be disastrous. The stress intensity factor, represented as K, measures the stress state near the tip of a crack. KISCC is the critical value of K below which cracks will not grow. If the stress intensity factor goes above KISCC, cracks can develop quickly, increasing the risk of failure. So, how does KISCC help prevent stress corrosion cracking? It sets a limit. By keeping the applied stress and the size of any defects in a material below this threshold, engineers can stop cracks from propagating. This means that careful design and material selection are vital. To effectively manage SCC, engineers focus on a few key areas. First, they design components to minimize tensile stresses and any residual stresses that may be present. This helps keep the stress intensity factor lower. Second, they limit the size of defects or cracks through rigorous quality control and inspection processes. This ensures that any flaws are small enough not to cause issues. Environmental factors also play a role. Engineers can implement protective measures to reduce the corrosive effects that can influence KISCC. This might include using coatings or selecting materials that are more resistant to corrosion. It's important to note that KISCC is not a one-size-fits-all value. It can change based on various factors, including the material composition, its microstructure, the environment it is in, and the type of loading it experiences. Therefore, understanding and measuring KISCC for specific materials and their environments is essential for effective prevention of stress corrosion cracking. In the context of product failures and mechanical breakdowns, KISCC helps explain why some cracks remain stable while others grow rapidly. By monitoring the stress intensity factors in relation to KISCC, engineers can predict and prevent failures caused by stress corrosion cracking. In essence, KISCC acts as a safety net. By keeping operational stresses and defect sizes below this threshold, we can prevent cracks from growing and avoid the failures that come with stress corrosion cracking. This approach combines knowledge from material science, fracture mechanics, and environmental control to tackle a common issue in mechanical breakdowns.